We had some banks with a problem.
So we've been talking to many customers, and we have seen that people, when they move into the cloud, they consider different options and they're trying to build something from scratch.
Now, so far so normal, especially if you're a bank or another financial institution. You want to look around and see what the current state of the art is, and then you want to build a technical structure you can stand on for some time.
Sometimes people come to us after they spend 6 months implementing something themselves, and coming across some of the problems that we have already discovered previously.
So 3 of our very clever and customer-obsessed solution architects who'd seen this happen a bunch of times put their heads together to create the HTC Grid on AWS project. It's an open source project that has their collective wisdom and experience built into it. Or in other words, you get to skip everyone else's mistakes and cut to the front of the line. What's not to love?
So HTC Grid allow customers to go and try the solution on AWS that is based on the best practices from our side, experience from many engineers, and they can very easily adapt it to their workload and see if it actually works for them. Considering the characteristics of the FSI workloads, when the customer would like to migrate on AWS, they have a multitude of different options. And what they need to evaluate is the latency, throughput, and the scalability of the solution, right? Mm-hmm. So technically, we have tried our best to combine all the 3 of these properties in HTC Grid. Mm-hmm. And out of the box, it can cover a very large spectrum of the workloads in FSI. However, where it is not fully optimized or not fast enough or not scalable enough, this is where you can take advantage of API-driven architecture, and you can replace some of the components that suit specifically for that requirement. FSI customers have quite a wide spectrum of the workloads, right? You already talked with Alex about the nightly batch, but they also have different types of workloads, such like intraday trades analytics, right? Mm-hmm. And these workloads, they have quite different characteristics. So for example, nightly batch is a high volume of tasks that needs to be run over the relatively long period of time, like a number of hours during the night. But they also have a very short computation during the day that needs to be served in pretty much near real time, right, in the response to the human interaction with the system. And these are different requirements for the system that customers often want to combine in one system.
Yep.
And ideally, they'll also want to have one architecture that can satisfy all of these requirements. So this is quite a difficult thing to achieve. However, we try to combine it in all of these properties in the HTC Grid and also make it adaptable.
Well, I think it's hard to achieve, but I think it's even harder to achieve if you were trying to do it on premises with a fixed cluster. Right? Because it just becomes the Hunger Games, where all of the different groups in the company are trying to beat each other to death to get access to a fixed amount of hardware. Having that stretchable aspect to the cloud makes it much easier to implement something like you describe. Different clusters for different groups, but
absolutely.
A single sort of set of assets that build it and manage it.
Right. So I think the high-level architecture that I'm showing here is can explain very well the idea, right? The HTC Grid comprised of 4 main components. We have a client application on the left-hand side that uses our library to communicate with the grid, basically send tasks, receive back the results. We also have a data plane, which is used to exchange the data between the clients and the compute nodes. We have a control plane at the bottom, responsible for scheduling the tasks, logging, monitoring, failure detection, recovery, and of course scaling the grid according to the load. And on the right-hand side, we have different compute planes that can be configured for the system. The entire system is API-driven, which allow us to change different components. It goes the same for the data plane, it goes the same for the compute plane. And basically, this is what allows us to build different HTC grids for different workload types that the customer might have, and also for different business units that want to maintain their individual grids themselves. So generally, overall architecture is pretty much, let's say, 80% the same, so that there is a knowledge transfer within the organization. There are people who understand how the system works, but the small components might be different. For example, if you look at a data plane, we can select Amazon S3 as a primarily storage. For example, if you're looking to transfer a large amount of data, also if you want to optimize for cost. Alternatively, if you're looking for intraday workload that requires ultra-low latency, we might want to go with Elastic Cache for Redis. And alternatively, if we want to have a POSIX file system, then FSX for Lustre would be the choice. And the great thing about it is that we can deploy 3 HTC grids within one AWS account, within one region. They can serve different requirements, different workloads at the same time.
And then over on the compute plane, you've got ECS, you've got EKS, and EC2 and Lambda. Characteristically, why would a customer choose any one of those over the other?
Today in our open source project, we have implementation for the EKS and ECS, and these are very popular options for the customers. So there is a lot of workload that are already containerized, and it is very easy for them to be moved. So implementation for Amazon EC2 and AWS Lambda, they're still in our roadmap. So overall, we are driven by the customer requirements. So if there's specific workload that require that, this is something that is relatively straightforward to implement. But by and large, the selection of the compute plane is driven by the workload characteristics and the customer's experience.
Right, so if they're already using Kubernetes, this probably makes sense for them to choose that as the compute backend.
Correct.
ECS would be what they would choose if they've perhaps been long-time AWS customers.
Absolutely.
Yeah. How does somebody get hold of HTC Grid?
So first of all, this is an open source project, and we provide a link there below. So you're welcome to go and try it out yourself. We also have a workshop published, which is it's publicly available on the internet. So you can go there, you can follow the steps, you can deploy it in your own AWS account, go through all the steps and understand how everything is working.
And there's a blog post about this describing a number of these things and actually showing some of the performance results, right?
Yes, we have 2 blog posts on the subject, and one of them is outlines the overall architecture and the principles behind, and also the reasons why things are implemented the way they are. And we also have a second blog post that was released just recently, and it talks about the performance characteristics that the customer can expect from the system. So we have tested the system. We were able to achieve the throughput of 30,000 tasks per second. And I have to tell you, this is not a limit. This is just as far as we went. Different FSI customers have different workload requirements, of course, but what we have seen is that some of them have hundreds of millions of tasks that need to be processed on a daily basis.
And so 5,000 to 10,000 tasks per second is probably getting up towards the high side of what somebody's going to need. 30,000 is crazy good.
It is. It is.
Good proof point that this thing works.
It is. 30,000 is probably more than what anyone needs right now, but the options are there.
If you're enjoying these videos, please give us a like and consider subscribing to the channel so that we can keep making more to help you understand how the cloud works and to show you new ways to help all the scientists and engineers around you who use HPC every day to do amazing things. It's what gets us motivated as well. See you next time.